Hello, everyone. Thanks for joining this session. Today, I'm going to talk about our long journey in terms of building out the OpenStack cloud system for Adobe. I'm Jun Park, a solution architect at Adobe, and this is joint to work with one of my colleagues, Agya Banerjee. Typically, when I share our story, it's kind of requiring 1 hour minimum. This session is just a 15-minute only, so I don't think I can really share all the detail level. So it was kind of challenging to me. Then I decided, okay, I may have some better strategy to utilize this 15 time more effectively. So I'm going to actually focus on the main message here during the 15 minutes. I uploaded this PowerPoint file. If you're really interested, you can really look at all the detail level, but I can really pick up one thing. But honestly, if you look at the title, he's what a boring title. I mean, I couldn't actually make a really fascinating title just like before the session, right? Mesos Cluster on OpenStack, something like that, right? In fact, in my slide, I have actually Mesos use cases, but I didn't use such a fascinating title. But, okay. So before talking about our long journey, the big message I try to deliver is that in terms of dealing with this kind of open source based project and the system, and always kind of you're going to run into this kind of common cases, and OpenStack is not exception anyway. So the way I'm trying to share is this. First of all, I try to make some template video. So there is a very interesting model named the Swiss cheese model. Is used to analyze how come disaster happen even when you have a multiple layer of defenses. So when each defense layer has its own bug, its own problem, and all those multiple layers lined up well, then sometimes disaster happen. Then unfortunately, our case is just like this Swiss cheese model. And actually, this is not rare. It's more actually over common things in terms of dealing with OpenStack environment. Even though this model is good, but I kind of realized that there are more two factors we need to actually consider. Some title kind of is big now here. As you know, that this is not about physics, of course, but let me just introduce interesting theory Einstein developed, right? So what he found, what he contributed to the physics world is that, okay, if you really try to analyze something, you have to think about space as well as time. So given the Swiss cheese model, we have to consider also time. And then one more thing, as you know, the CERN working on the latest theory of physics, Higgs fields and Higgs boson using OpenStack environment, interestingly. This theory is all about interaction, about all the elements. So we have three elements right now in terms of analyzing disaster. So first, space, time, and interaction. So this is our template for this talk. So y-axis has a component in OpenStack, and then as time goes, and then some component has correlations in the dependency. So in red, in this template means that there's something bug and issue, and green is kind of bug fix. So this is survey result, May 2015. Most common architecture in this OpenStack community right now, Ubuntu system as their basic operating OS, and KVM for hypervisor, and OpenvSwitch for their networking part, and Ceph as a backend storage system. Now, our Adobe architecture exactly matching with this common architecture. If something is really common and the expectation is, supposed to be really working well, but actually it's not. This is from a kind of user perspective. Let's say user created one project, and then, in fact, actually, Super Adobe actually created, and then in their project they created, let's say, 3 VM, and then one VM may have multiple number of interfaces, and each probably, directly, related to provide network with the security group, and each one may be based on the VXLAN private network. This is very conventional, nothing special. And then our backend storage system is Ceph. If you look at a little bit more detail level of a host level, and as you can see here, there's a Linux bridge there, and then OpenvSwitch and Banjiro interface there. As you know that OVN, the Open Virtual Network, is a project is launched, and then they're really dealing with get rid of this Linux bridge in this picture, but still they have to use a Linux bridge because of some kind of limitation of OpenvSwitch right now. Okay, so now this is one template analysis we went through when we built out this. Actually we're using iSouth version. So for example, if you think about the networking part, okay, you decide to use a Neutron, and you decide to use OpenvSwitch and on Ubuntu system, and this is perfect matching environment. But this is really happening. Basically, we backtracking down what was going on each component side, how they correlated to each other, and then how we got screwed up. Okay, so if you follow the red color, so somehow the obvious side that they decided to launch the LTS version, which is 2.0.1. It has really awesome features like a megaflow and the multiprocessing. Everyone was waiting for. But unfortunately, there was a hidden bug. For example, when Neutron tried to add a port with this OBS version, it's completely randomly crashed down. And when OBS crashed down, of course, the Neutron could not do what he's supposed to do. So here, what happened is that nobody knew that at the time, and the Ubuntu system announced that another LTS version, what I'm saying is a trusty version 14.04, and then they include that problematic OBS version as default module. And everyone tried to install that. Okay, trusty, there's a version, and then install that, and then try to run this OpenStack with the Neutron OBS. Of course, screwed up. And then people try to understand why only my environment doesn't work. A lot of people using only Neutron and OBS. So this is not about blaming or something. This is very common phenomenon in virtually any kind of open source project, because see here, Neutron itself is a separate open source project. OpenvSwitch also completely separate independent project, and Ubuntu as well. But somehow they really correlated from our perspective. We have to use all together anyway, in a very nice way. But we cannot really tear down those stuff. So anyway, bug fix already available during that time, but it was too late because already they announced. And then in fact, how long it takes to really accept those bug fix? May 15. But we already released out this environment to February 15. So how could we do that? Of course, we just analyze all this stuff. We pick the right version of OBS and then replace it. It's perfectly working. But interestingly, during that time, if you have a different template here, what's going on is that we have every 6 months released out. And then during that time, I could hear a lot of FOD means fear and uncertainty or doubt, like without really understanding what's going on. And some people just complain about, okay, Neutron is broken. Well, sometimes it's not really, because OBS is broken. If you select the wrong version of OBS, then you don't know, So that's why, I kind of saw that a lot of, FOD is going on, spreading out without really understanding what's going on here. So that is a very interesting kind of phenomenon in this networking part. Well, anyway, so we have a bunch of other templates like this. Every component, when you use a Cinder, Ceph, Ubuntu system, there's some kind of problem with the Ceph itself. And when you use KVM and kernel, Ubuntu specific kernel itself has some specific XF deadlock bug there. So it's kind of all component correlated each other, and then making So this is really matching with the first slide of the Swiss cheese model. It's kind of more common. Anyway, so we figured out all this stuff. So finally, we stabilized our environment. So let me just share quickly checklist here. So you need to understand what you're doing. For example, okay, OBS side, if you really want to use OBS. And Neutron itself sometimes still there's a scalability issue, and then we actually cherry pick the relevant bug fix. And then back then, iSouth, they didn't have the the QoS stuff at all, so we manually kind of utilized that out of band rate limiting functionality against the OBS. And then this morning I attended some very interesting session. Finally Liberty has official QoS functionality. So if we use Liberty, we don't have to probably doing this kind of out of band rate limiting at all. But we right now using with Icehouse, and then you need to carefully think about MTU size and the right size and an obvious structure, and make sure to turn off all this problematic optimization technique, GR or LR. If you enable that, then you easily screwed up. And so the storage part. One of the fundamental rules is that kind of decouple out the separated logical service with the OpenStack API service. If you have Ceph monitor node in the same node, and then, yeah, basically it's going to be very hard to track down what's going on. Anyway, so we did a lot of kind of high stress testing, and I figured out. So after the talk, if you have any question, I can share how we really tested and found the scalability issue. And the question is, okay, how many boxes in here? Okay, still there's ambiguous stuff still remaining. I don't think we completely figure out what's wrong over there. But still, we continue to do that. So I like this quote from Einstein. He's just saying that, okay, I'm just to stay with the problem longer. So we definitely, continue to stay with the problem longer. There are a lot of response about that this kind of messed up situation. So OpenStack already react. Okay, we understand the problem. We try to really fix that problem. So 1 minute probably. I'm going to just show really quickly. Typically, I just really do live demo actually. Mesos Cluster. So using the heat template on this Icehouse version, actually OpenStack, typically I just really provide live demo. So running template, and then you can deploy the Mesos master with the Zookeeper marathon, and then whatever number of a slave, and then finally you got this entire structure in mostly like a 2 minute, and then you can inject a microservice through this framework. And this is all screen capture rather than really doing live demo. I just got a lot screen capture from my live demo. So you can see here, like, okay, master, and then his stack already automatically created, and then structure, and this is marathon UI, and actual microservice running, and this is a Mesos UI. So pretty much that's all today. Thank you.